So hello again, it is the third and last video about efficiently computing powers modulo n. So this is still the expression. We have to compute 19 to the power of 23 modulo 29. So the way we can handle it is by doing a little work on the exponent first and actually expressing this exponent, which is 23, as a sum of powers of 2. That is trying to get some binary representation of 23. So here that's quite easy to do, and having a decomposition of 23 as powers of 2, so namely 1, 2, 4, 8, 16, 32, and so on and so forth, leads to 23 equal to 16 plus 4 plus 2 plus 1. So now the expression we have to calculate is 19 to the power of 16 plus 4 plus 2 plus 1 modulo 29. And then we can apply a well-known rule that a number to a power of a sum of other numbers is equal to a product of powers. So we can write that this is equal to 19 to the power of 16 modulo 29 times 19 to the power of 4 modulo 29 times 19 squared to the power of 29 times 19. So here we have 3 multiplication instead of the 23 that were necessary in the previous algorithm you've seen before. But nevertheless, we still have to compute individually all the term of this multiplication. And what's nice is that those terms are quite easy to compute, because another trick is that 19 squared modulo 29 is 19 times 19 modulo 29. So we can get 19 squared from 19. So that doesn't sound very interesting, but where things are getting interesting is when we write that 19 to the power of 4 modulo 29 is 19 squared. So we need only one multiplication to get 19 to the power of 4 from 19 to the power of 2. And if we go on, actually, we also have to compute 19 to the power of 8, even if 8 is not a power that appears in 23, because we will need 19 to the power of 8 to calculate efficiently 19 to the power of 16. So during these steps, we will compute all the powers of 19, powers which are themselves powers of 2, and we will only use those we need for the final calculation. So 19 to the power of 8 is 19 to the power of 4 modulo 29 squared. And finally, we can reach very easily 19 to the power of 16 from 19 to the power of 8 squared. So this means that we only need 3 multiplication for the final result, and then to generate all the individual terms or parts, we need here 1 multiplication, 2, 3, 4 multiplication. That's why this system is very efficient, because from a decomposition of the exponents and quick calculations, one can drastically reduce the number of operations which are necessary to calculate that. So now let's handle this from a little table, which is here just below. And from the decomposition of 23, we will first fill the last column to see which powers are necessary to get the exponents. We'll have to calculate all of them, but we won't use all of them for the final result. So power 1 appears in the decomposition of 19 to the power of 23 modulo 29. So yes, 2 appears as a power, 4 appears as a power, 8 doesn't appear as a power, and 16 appears in the exponent. So this is the first thing to do. And now let's just do some calculation. So 19 to the power of 1 is 19. Modulo 29 is still 19. 19 squared is 19 times 19, which is equal to 361. Then we can apply modulo 29. The result is 13. So we start from 13, which is 19 squared modulo 29, and compute 19 to the power of 4 with 13 times 13, which is 169, and applying modulo 29, the value is 24. And we go on here with, let's say, little and value that are quite easy to calculate. It's 576. Modulo 29 is 25. And here we have 25 times 25, which is equal to 625. Modulo 29 is 16. So now, once this table is filled, we keep all the values with the powers that appear in the decomposition. So actually, 19 to the power of 23 modulo 29 is equal to 19 times 13 times 24 times 16 modulo 29. This gives a quite reasonable number, but we can even be more efficient if needed, because all of these operations we can do and apply modulo 29. So in order to get the results, 19 times 13 is 247, to which we apply modulo 29, which gives us a 15. 15 times 24 is 360, to which we apply modulo 29, which gives us 12. Now, last operation, actually, 12 times 16 is equal to 192. Modulo 29 gives us 18. And that's the final result. So we know with this kind of operation that 19 to the power of 23 modulo 29 is equal to 18. We've done that by calculating efficiently with numbers which are not so huge. Actually, the biggest number we've written so far from the table is 625, and applying modulo 29 is quite easy to do, even with a standard calculator or a computer. So I hope this explanation was clear and that now you're able to apply this kind of method to calculate some powers modulo n.